Okay, now I'm going to go over the conservation of energy equation, and I forgot to mention last video, but this video, the PDF file, I'm going to share it in Schoology too, so you can just see the notes without this video, but this is for the people that want to see me go through it step by step. All right, so what I have here is that the same energy before and after. So what that means is for conservation of energy, whatever energy you have in initial case is going to be the same thing you have for the after case or the final case. From this point on, I'm going to put EI as E initial equals EF or E final. E is just going to be the sum of the energies of different cases. So let's say we have potential, kinetic, and thermal energy. That's going to be what you see here. E equals PE plus KE plus TE. All right. So let me give an example of that. So we have kinetic energy is 1,000 joules, potential energy is 50 joules, and thermal energy is 250 joules. So if energy is a total sum of all those individual energies, what is the total energy for this case? It should be pretty easy. I have it down here. E equals 1,000 plus 50 plus 250. If you do that in a calculator, which I don't think you ever need one because 50 plus 250 is 300. You just add that. You get E equals 1,300 joules. So that's pretty simple, but now let's do it in terms of an initial energy and a final energy. So I have these cases. The initial energies I have here, I put the same energies as before, 1,000, 50, 250, and now have final energies with KE is 100, PE is 700, and TE is 500. There's something you should notice between these two energies. Just a hint, it's based on their sum. So let me give you a few seconds to look through that to see what you notice, and then I'll go through it together. Also, at some point, I also ordered a drawing tablet, so maybe I can actually do this by hand while actually recording a video. So we'll see how that goes later. All right, so right here, I calculated the total. Like we did last time, it's 1,300, but this time 100 plus 500 is 600, plus 700 is 1,300. So EI is 1,300, EF is 1,300. They must be the same. Like we mentioned before, energy must be conserved. So whatever is the energy in the initial case must also be the energy in the final case. So knowing that, you can actually find, let's say, one of these energies if you know all the other ones. So let me give an example of that. I did it simpler with just potential kinetic. I said the initial potential energy is 500 and the initial kinetic energy is 500. Then I have the initial potential, final potential energy is 700 and the final kinetic energy is a question mark, or we don't know it. So like I mentioned before, EI must equal EF. And since EI and EF are the sum of each individual parts, we can just put that equation down here. PEI plus KEI equals PEF plus KEF. We know all the numbers except KEF, so we can just plug it in to solve for it. 500 plus 500 equals 700 plus KEF. In this case, you just have to use algebra just to solve it. And this should be a pretty simple calculation, so let me just go through it. 500 plus 500 is 1,000. 700 plus KEF, you just leave that down here. Then what I did now is subtract 700 to both sides, like you do in algebra, like assuming this is an x. So 700 plus x. So minus 700 minus 700. Then we have KEF equals 300 joules. So this is, you can visualize it by numbers, but we also visualize this with actual diagrams, which is called, and the name is kind of silly, but LOL diagrams. I'll go over why it's called LOL diagrams, but you might have an idea by watching the video I sent you for Khan Academy about LOL diagrams. So the next video I'm going to give you is just me going over an example of a situation where we use an LOL diagram. All right, thank you.